A very fine good evening to you all. On behalf of Department of Computer Science and Engineering, France Xavier Engineering College, on my own behalf, I welcome you all to this webinar on advancements in processes. The resource person for today's webinar is Dr. T.S. Arulanand, who is working as professor in Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad. The coordinators for this program is Professor S. Malayarasan, Professor M.A.Y. Peer Muhammad Appa and Dr. E. Manohar. The program is organized under the guidance of Professor P. Brinda, Head of the Department, Computer Science and Engineering Department, Mr. S. Krishna Kumar, Director Alumni of France Xavier Engineering College, Dr. V. Velmurugan, Principal of France Xavier Engineering College. So, on behalf of the department and behalf of France Xavier Engineering College, I once again welcome all of you to this webinar on advancements in processes. I request my colleague, Professor M.A.Y. Peer Muhammad Appa, to give the welcome address. Hand over to Professor M.A.Y. Peer Muhammad Appa.
Very good evening, one and all. It's my great pleasure to invite you all to this webinar on advancement in processor. We welcome and thank the management of Francis Xavier Engineering College, our chairman, our managing director, Dr. Jaykumar sir, the general manager development, and Dr. Velmurugan sir, our principal, and our HOD madam, Mrs. Brinda ma'am, for giving this opportunity and the support to conduct this webinar in a grand manner. It's my honor to welcome and the resource person, Dr. T.S. Arulanand, Professor, Department of Electronic and Communication Engineering, MLR Institute of Technology, Hyderabad. I welcome and the coordinator, Mr. Malayarasan, Dr. Manohar, Assistant Professor, CSE Department, and all my colleagues of CSE Department and all the participants.
Thank you, Professor M.A.Y. Peer Muhammad Appa. I would like to introduce the chief guest of today's webinar on advancements in processes. The resource person of today's webinar is Dr. T.S. Arulanand, who is currently working as Professor in Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad. He is having a wide experience in teaching profession of 15 years. His area of interest is image processing, communication systems, as well as embedded systems. He published more than 35 papers in Scopex indexed journal. He is also an alumni of Francis Xavier Engineering College. He is the first batch student of Francis Xavier Engineering College. Not only that, he received many awards. He received the award of IGIP Best Engineering Educated Award 2020 as well as International Institute Organized Researcher Award of 2018. I am happy to introduce the chief guest and my friend Dr. T.S. Arulanand. I hand over this session to Dr. T.S. Arulanand for the webinar on advancements in processes.
Good evening all participants. This is Dr. T.S. Arulanand, currently working as a professor in the MLR Institute of Technology at Hyderabad. I am very much proud to introduce myself. I am the first batch alumni of Francis Xavier Engineering College. My research interest areas are embedded system, image processing, and communication system. I first of all thanks to Francis Xavier Engineering College management, principal, and organizer of this webinar. I am going to present today my webinar topic on advancements in microprocessors. So today let me start with the microprocessors. What are the advancements from the 1948 onwards till date? What are the developments happen in the microprocessor up to today's date? We are using processors in our computers laptops, and smart mobile phones. First, we see about course rationale. Why we want to study or get knowledge on microprocessors? The microprocessors subjects provide understanding of microprocessor hardware and software fundamentals. So also it gives technical computing and also the students are able to design the projects or develop the hardware by using their assembly language programs. Course objectives. What are the objectives of studying this course or especially this webinar? Introduce the evolution of microprocessors, define the applicable microprocessors, microcomputers, and microcontrollers. Program applications of microprocessor, microcomputer systems. Introduce two assembly language programs. Describe the purpose of microprocessor and internal registers. Course outcomes. After end of this course or the webinar, students can or the participants can introduce about the evaluation of microprocessors and they familiarize with the assembly level programming, apply the concepts on real-time applications. First of all, we discuss about what is microprocessor. So from the term itself, microprocessor is a combination of micro and processor. The processor means a device or a equipment that performs some process on it. So it will process the binary data like zeros and ones. The microprocessor manipulates the binary data. Next one is, let me compare with microprocessor and microcontroller. Before I explain what is microcontroller and microprocessor in a single statement. Microprocessor is a device. It can perform all arithmetical, logical, and other operations, but it does not contain any inbuilt memory or inbuilt I/O ports. Whereas the microcontrollers act as a single chip computer. It contains all the functionality of the microprocessor as well as it have their own inbuilt memory, timers, I/O ports, serial interface, etc. So here there are multiple points are compared with the microprocessor and microcontrollers. So microprocessor is the heart of the computer system, but the microcontroller is a heart of the embedded systems. So microprocessors, cost of the systems is increases, whereas cost of the microcontrollers are comparatively low. In microprocessor, we need to externally access the I/O devices and memories. But in microcontroller, I/O ports and memories are available inbuilt. Microprocessor does not have power saving features, whereas microcontrollers having that power saving features. Microprocessors are based on the von Neumann architecture model, whereas microcontrollers are based on the Harvard architecture model. For some of the applications of the microprocessors, it can be used in the personal computers. but the microcontrollers especially can be used. Some of the examples as washing machine, MP3 players, traffic lights, etc. So just I have introduced first about what is microprocessor, what is microcontroller, and both are compared. Now, what are the other key terms we going to be covered in our webinar are generation and features of each processor, buses, stack and queue, pipelining, interrupts, instruction set and introduction, timing diagram, addressing modes, advantages, applications, like this all the major key components which are going to be covered in the today's webinar. So everyone must to know when it was started. The microprocessors are started around in the year of 1950s. Actually, the first processors or the first generation processors are named by 4-bit processors is introduced by the Intel, and it is namely it is called by the processor is Intel 4004. 4-bit processor means the processor can process the 4-bit data at a time. So how you are defined the processors are 4-bit, 8-bit, 16-bit, 32-bit, 64-bit or 128-bit. That all depends on their data buses available in the system. For example, in 4004, Intel 4004 processor having 4 data lines, hence you called this processor as 4-bit microprocessor, and it was introduced around in the year of 1972. So thereafter the processors developments day by day happen. The next the specific processor introduced is 8080, that is in the year of 1974 with inbuilt transistors of 6000, and it is a 8-bit processor, operating frequency of 2 MHz. So every processor speed is determined through their clock speed. So we know the relation between time and frequency. T equal to 1 by F. So if the F is more, the value of F is more, then the T is less because of the inversely proportional of this T and F. So frequency is increased, time required for the process is get decreased. So day by day, year by year, the developments on the microprocessor due to the technology changes, especially in VLSI, developments change to the microprocessor developments like 8085. It introduced in the year of 1976 with 6500 transistor, and its operating frequency is 5 MHz. Then it is 16-bit processor introduced later the year of 1978. 86. It is contain 29,000 transistors inside, and its operating frequency are 5 MHz. And that's almost in the same year, 8088 is another processor. It was introduced, that also a transistor contain 29,000 transistor functioning, but it is just 8-bit processor. And later the stage the development is came to 80286 in the year of 1982, and 386 by 85 and 486 by 1989, with the drastic improvement of transistor package, and also the data width also improved from 4-bit to 8-bit, 8-bit to 16-bit, 16-bit to 32-bit. Like 80386, 80486 processors use 32-bit processors, and their operating frequencies are also reasonably increased to 16 MHz and 25 MHz respectively. Further, Pentium processors, 1993 in the year, the number of transistor package is drastically improved, and the Pentium processors are available in 32-bit and 64-bit in data bit size, and its operating frequency also too high, it is 60 megahertz. Then the stage by stage, Pentium 2, Pentium 3, Pentium 4 are the processors are developed in the years of 1997, 1999, 2000 respectively, and its operating speed also drastically increases from 4-bit processors to 16-bit processors according to their clock speed or clock frequency. So here just I am showing some of the layout of the developed processors like 4004. Intel 4004 is a first processor. How it is an internal view, and the Pentium processor is a green one, and the 8008 is another processor, and how many transistors inside it packed, how much nanometer technology they are followed, that all the things are named there. For example, 4004 is used 10,000 nanometer technology, and Pentium processor 3.1 million transistor in 800 nanometer technology. 8008 is 10,000 nanometer technology. Like this all the packaging density of the transistor inside the microprocessor ICs. So the later the stage, the Pentium processors, how it was, and dual core processor, how it was. So, and their internal layouts are shown in this slide. This is some of the detailed information about the evaluation of the microprocessors only. So, which year it was introduced in first processor in the name of Intel 4004, and parallelly that same year the Motorola, they have introduced their processors in the year of 1972, that is with the name of Motorola 6800. It is a 8-bit processor, and second generation processors are introduced in the year of 1974. The first processor is in second generation is 8080, Intel 8080, Zilog and Z80, Motorola 6800 are almost in the category of second generation, and these all 8-bit processors. This processor contains CPU, ROM, RAM, clock ports, and a single package. In 1976, Intel 8085 8-bit microprocessor was introduced, and Zilog was introduced their processor in the name of Z80. These two processors are very common in that period of 1972 and the later stage, because these two processors are powerful, has powerful instruction set. So till date, everyone knows 8085 processors is in live. Third generation processors are like 8086. This is a 16-bit processor introduced in the year of 1978. At the same year, Z8000, that is the product launching company is called Zilog. It is Z8000 in the year of 1979, and the Motorola launches their product with the name of 68000 in the year of 1980. And these processors have their memory space of 64 KB. Like we know 8085 processor and Z80 processor and Motorola 68000 processors all in the category of 8-bit processor and able to access the maximum size of 64 kilobyte of memory. So the memory accessing capability is determined by size of the address bus. Initially I said the processor is called by 4-bit, 8-bit, 16-bit or 32-bit processor, that is based on their data bus length, whereas the memory accessing capacity is based on their address lines. The buses is generally called wires, nothing but wires. It's carrying the information from one place to another place. It's a general meaning. What is the role of the bus? The bus in the road, it's carrying the people from one place to another place. Like here, the bus is carrying the information from processor to memory or memory to processors, like registers to memory, memory to registers, like vice versa. Anywhere it can use to transfer the data from one place to another place called a database. that address transfer from one place to another place is address bus, and the bus which used to control the functioning of the microprocessor you can call by control bus. So every microprocessors, they have their own bus systems. The buses are much important, namely I said data bus, address bus and control bus, and also explain their roles. Data bus carrying the data from data to that is processor to memory, or memory to processor, or external device to process memory, or memory to processor. Like any combination of transferring, it is possible. Like address buses, it is unidirectional bus. It can only travel from processor to memory because and processor to IO devices, because the address is sent by only the processor to search the locations in their memory. Hence, this bus is not a bidirectional bus. But whereas the data bus is bidirectional, it can transfer the data from memory to processor, processor to memory, IO device to memory, memory to IO device. Hence, data buses are always bidirectional, and address bus and address buses are unidirectional, and control buses, most of the buses are having unidirectional compatibility. And the next next is Intel 8086 is a 16-bit processor, and Zilog 8000 is another 16-bit processor. That all comes under third category, third generation only. In fourth generation, processors are introduced in the year of 1981 with the data width of 32 bits. Like the name of the processor is called 8386, and with that memory capacity of 4 GB. So meaning that to access the 2 GB of memory, how many address lines required, that you can calculate. 2 power which number it's make the 2 GB. So already explained, the address buses only decide the capacity of the accessing memories. And almost and the same year, Motorola have introduced the processor 68020 is another 32-bit processor, and fifth generation processors called by Pentium processors. So the Pentium processor generation is made a very big change in the computer developments. The Pentium processors are powerful processor than the previously existing all 8-bit, 16-bit processor, because this is 32-bit processor. It's have 4 GB of memory capability, and it is operating frequency also 60 to 200 megahertz. Because of this operating clock frequency, the speed of the Pentium processors are increased. So that made very big revolutions in the computer developments. And next is Pentium 2 processor in 1999, and it also 32-bit, but the memory size is enhanced from 4 GB to 8 GB. And Pentium 3 and Pentium 4 processors are almost in the year of 2000. These processor speeds are enhanced to 3 to 1.3 gigahertz, 3 megahertz to 1.3 gigahertz, and Pentium 4 processor 1.3 to 1.5 gigahertz. And both processors are 32-bit, and it's capable to access the memory of 4 to 6 GB. And Itanium is another processor. It was introduced in the year of 2001. Its operating frequency is more than the previous processor like Pentium 3 and Pentium 4. It was introduced the year of 2001, and it is able to access the memory of 12 GB, and this processor is called 64-bit processor, meaning that it has 64 data lines. And sixth and seventh generation processor is the later stage of 2016-17 in the age here. The processors are introduced up to i3, i5, i7. These processors respectively 6th and 7th generations they called. i3, i5 called generation 6, i7 is in the generation 7. these processors have more speed, the operating frequency and other things I will show in the next slides, and it supports larger memories, and it is able to perform the multi-threading process. So here you can see here once again that tabulation about the development of the processor and the number of transistors. In addition, one more point is included. There is instruction per second. That is much important. Instruction per second is says that that is speed of the processor per second. How many instructions it can be executed? That is even 60,000 can be executed per second. And next processor 8008, it is 8080, 8085 processor. How much instructions per second? The speed of the processor is determined through instruction per second, and their clock frequency also given. So the clock frequency and instruction per seconds have the close relevance. So the clock speed is increased, automatically instruction per second also get increased. So the next processor is 8086 processor. It's around 2.5 million instruction per second. So this is another 16-bit processor, and these all the processors are 386, 486 processors that are 32-bit in size, and their capacity of instruction, how much it can be do, and Pentium processors. So Pentium processors introduces the cache memory facility also. So cache memory is an important concept. So cache is a portion of the memory which are used to hold the data which are very frequently used. Which are the data very frequently used by the processor. That data has to be stored in that specific area of memory you can call by cache memory. This data's processor can easily access without searching the whole data space. It can easily search and find that memory location, the data from the memory location, that is called a cache memory. Then these are the Intel Core 2 processors, what is their capacity and cache size, and i3, i5, i7. So their processors with what are the range of speed, 2.2 gigahertz to 3.3 gigahertz for i3. For i5 it is 2.4 to 3.6, and i7 2.93 to 3.33 gigahertz range of speed. And these processors having that is multiple hundred of million transistors functioning inside the chip. This all happened due to the developments of the VLSI technology. So this information is about only this i3, i5 and i7, the recent processor Intel Core i3, Intel Core i7, Intel Core i5. These processor features are one by one. It was discussed here. Number of cores. It is used as a personal computer. i3 processor is used as a personal computer, and it have two dual core like Intel Core i5. It have 4 cores. It has 4 cores, and Intel i7 has 4 cores. And the next point is the same i3 processor clock frequencies are discussed here. Here it is discussed the clock frequency of each i3, i5 and i7. And next one is turbo boost. What is this turbo boost? I will share in the next slide. So meaning turbo boost is a facility to improve the operating speed of the processor. Even their clock frequency is less, it able to boost up to higher speed by the facilities called turbo boost. That I will show in the next slide. And the next point is hyper-threading. That also shared in the next slide. The facility is available in i3, i5 it is not there, i7 have that same facility, hyper-threading. And cache memory facility, it is for i3 processor having 3 to 4 MB, and i5 processor having 4 to 6 MB, Intel Core i7 processor having 8 megabyte MB cache memory. So here just I highlight about. So if more number of cores to the processor, what is advantage? In the first point it is covered. There we discuss i3, i4, i3, i5, i7 processor have their number of cores, 2, 4, 4 core processors there inside. So the number of cores in the processor, it drastically increases the speed of the program running. So then what is hyper-threading? So hyper-threading is a clever way to let a single core handle multiple threads. So that is a facility is given by the hyper-threading. And turbo boost. So turbo boost is drastically increases the clock speed of the i5 to i7 processor when more power is required. So the three key terms are here discussed. One is about core, number of cores available in i3, i5, i7, and hyper-threading facilities there are not, and turbo boost facilities there are not. There are already discussed in previous slide. So next it is the classification of the microprocessors. The microprocessors basically they are classified by CISCO processor and RISC processors. And more than that also super processors are there. Just majorly the processors called RISC and CISC. Complex instruction set microprocessor and reduced instruction set microprocessor. And the CISC processor, some of the examples are highlighted here, like IBM 370/168, BAX 11/780, or the processor which used the CISC instructions, complex instruction set microprocessor. So this processor minimizes the number of instructions per program and ignore the number of cycles per instruction. So minimize the number of instructions per program. That is a major function of this CISC processors. And the RISC processors are made according to their function. It reduces their execution time by simplifying their instruction set. That's why it is called reduced instruction set microprocessor. And they can carry out small things to specific command. This processor complete commands at a faster rate, and it requires only one clock rate to implement a result, a uniform execution time, and also it uses store and load instructions. So here some of the points were compared from CISC and RISC processor. Is a prominent hardware, RISC is prominent on the software. It is high cycles per second, it is low cycles per second, and it has transistor used for storing instructions which are complex. Here more transistor used for storing memory. Load store commands are available for memory to memory, and load store register to register in RISC processor. And the last point is CISC is induced in instruction, but this RISC is an independent. And the next classification is superscalar microprocessor. Previously, CISC and RISC were discussed. Now the superscalar microprocessor. This processor can perform many tasks at a time. That you can call it by multitasking. So single processor can perform more tasks at a time. That is called as multitasking. That features in superscalar microprocessor. And application specific integrated circuit, ASIC. So these processors are applicable for a specific purpose, like for a personal digital assistant computers. They are designed according to proper specification. The next processor is digital signal multiprocessors. Like simply you can call by digital signal processors, like these processors processing on digital data, and it will convert the analog data into digital and digital to analog, vice versa. These digital signal microprocessors are very commonly used in radar, sonar and home theater applications. And next is some of the advantages of the microprocessor, and they are high processing speed, that is according to the evaluation you listen there, 40042, there is i7 processor up to, how the processor speeds enhanced, and next is compact in size, the processor size are reduced. The size of processor reduced is made very big advantages on the product developing companies, like the laptops and tablets, smartphones, that all get reduced the size of the processors. Hence, the size of the whole unit of the device also reduced, like a tablet, like smartphones, and are many other gadgets today available, which are used to the recent microprocessor, which occupy less space, and that's consuming less power, and it can perform the complex mathematical operations, and it is very flexible, and this processor can improve according to the requirements. So this flexibilities helps to modify this requirement of the microprocessor. Some of the drawbacks identified is overweighting occurs due to the overuse, performance depends on size of data, and large board size than microcontrollers. Most microprocessors do not support floating point operations. So the last point is which valid. The floating point arithmetic operations can't be done by most of the microprocessor except the recent microprocessors. So this is simply the advanced system block diagram. One advanced microprocessor system block diagram. What are the modules are there? Like the central unit is called CPU, which is run by the clock. As you can see there, the clock frequency is 1.8 to 3.8 gigahertz range of clock frequency is applied to this processor, and it has ROM, flash memory, then audio video facilities, the peripheral interface like keyboard, mouse, scanner, USB, and more than that, and mass storage memory, and a network communication module, wireless, Ethernet, optical, that all, and graphics unit, like a PCI slots through we can interface the graphics, and this is about the power unit of the CPU. So these are the major units attached with the CPU of the recent processors. So there in 8086 processor, that highlighted feature is to be addressed. I forgot there to address there when I giving the introduction about the processor 8086. The pipelining feature. The pipelining is one of the feature of the 8086 processor, and the later stage of all processor had that same feature. So in previously the beginning stage of the microprocessor like Intel 4004, 8080, 8085 processor can use only the one operation at a time. For example, the three major stage of execution of every instructions are fetching, decoding, and executing. So during the fetching, the processor only do fetch operation, but in microprocessor 8086 it introduced these two modules in the architecture, name of execution unit and bus interfacing unit. that features help to perform, that is processes, means fetching, decoding, execution process in queue. So the fast operation of execution or fast execution of the instructions can be made by pipelining technique. So that is a feature introduced in 8086 processor. And now just going to be highlight about very common points about the processors like interrupts, instruction set, and addressing modes. Including of these three, I am going to be conclude this webinar. First about the instruction set. The 8085 or 8086 or any processor till date up to i7, each processor they have their own instruction set. That instruction sets are much powerful. Make use of this instruction set. The programmer can do the programs for any purpose, for any arithmetic operations, any logical operations, shifting, rotating, loading, like storing. There is multiple kind of operations can be do it by their corresponding instructions. But the later stage of processor have very powerful instruction than the olden age processors, because the later stage processors are reduces the instruction set. By single instructions can do more than one operation at a time. For example, even 805 microcontroller, comparing and jump operations can be do it together by a single instruction. But in microprocessor 85 or 86, that you have to do it by two operations. Compare to be do it by one operation and jump to be do by another one operation. But in the recent processor after the microcontroller 8051, these process controllers are giving these facilities like performing more, that is more than one arithmetic operations or the logical operations by a single instructions. So 8085 instructions and 8086 instruction or any processor instructions you can classify it as based on their operation, data transfer instruction, arithmetic instruction, logical instruction, machine control instruction, and stack operating instruction. So these are the major classification of the instructions available in the 80, 85, 86 and Pentium processors also. So these instructions are written by mnemonics. We called by mnemonics. The mnemonics is contained the field namely opcode and operand. So the opcode is explained to the processor what is the operations have to do. For example, move or add or AND or XOR, shift, rotate, like what operations processor have to do, that will be specified in the field of the mnemonics called opcode. And the operand will be the data or address, the operations to be do on which data. The operations to be do on which data is represented by operand field of the instruction, every instructions. So according to the 8085 processors, the instructions are in different length. Even it is applicable to all processors, like 1 byte instruction, 2 byte instruction, 3 byte instruction. Like the length of the instructions are varying from 1 byte to there is 3 byte instructions. So every instruction takes its own time for execution of that instructions. For example, 1 byte instructions may execute quite faster than 3 byte instructions. So the speed of the operation already I explained, that is based on the clock frequency of the particular processor. The clock frequency of the processor is more, then the speed of the processor is also more. The commonly used in the machine cycles in the every instruction execution is opcode fetch, memory read, memory write, IO read, IO write. These are very common. What the opcode fetch machine cycle is do is fetching the opcode of the command, fetching the opcode of the every command from the memory. So next is memory read. It will read the data from memory. Memory write. It will write the data to the memory from processor to memory. And like IO read, you can read the data from IO device. Then IO write, you can write the data to the IO device. So particularly output device you can make write operation and input device you can make read operation. Example, the keyboard. When you interface a keyboard with a processor, you can read the data. That means the operation you have to do is IO read. So for example, you have to print. So that time this printer is act as output device. The command will be sent from the processor to the IO device. So there you have to use memory write operation. So IO write operation. So the data is write from the processor to the external peripherals or the IO devices. So and compare instructions are there, shift instructions are there, shift right, shift left, rotate left with carry, rotate left without carry, rotate right with carry, without carry. Like multiple commands are available in every processor. Store string, like many operations can do on the string also. So that is the advancements in 86 processor over 86. So next I am going to be just introduce about addressing modes. Addressing modes explain to you how the processor read the data or address from the memory. How the processor is read the data or memory address from the memory or IO devices. So like different addressing modes are supported by the processors, like direct addressing mode, indirect addressing mode, implied addressing mode, immediate addressing mode, register addressing mode. Like in 86 processor, some more instructions also there. Some more addressing modes also there. Hence that register relative addressing mode, register indirect addressing mode, register index addressing mode, string addressing mode. So like there is many addressing modes are available in every processor to access the data and perform the operations. And the next one is about interrupts. So interrupts is a disturbance. Is everyone you know? Interrupt means a disturbance. Even we are using the phone. You are just watching the WhatsApp. You get a call. So which will get the higher priority. So interrupt is a disturbance, and which conveyed to the processor the request came from the input device or the output device. So when the interrupts come, the whole processor operations are hold, and according to the priority of the interrupt, that to be serviced first. For example, that I said now, when we using the phone, you are reading the message, you call is come, so that will be getting as a higher priority to your mobile interrupt. So then that will be getting on or turn on. This call will be getting turn on. Like many concepts can explain through the interrupt. So interrupt is follow some procedure called interrupt service routine procedures. These procedures helps to service the interrupt of the every request. The request may come from the processor, the request may come from the any other devices. So the request to be serviced by the software or the set of instructions you called interrupt service routine program. So that program run and complete the interrupt based on the interrupt priority. So which interrupts having more priority, that interrupts to be serviced by the processor first. And next I talk about the stack and queue. So stack and queue, you know, stack is what and queue is what. The stack is a memory, it will be accessed by last in first out, and the queue is a kind of memory, it will be accessed by first in first out, FIFO and LIFO. So for example, in 86 processor, the queue register is used to perform the pipelining operation. The queue registers, the size of the queue register in 86 is 6 byte. That 6 byte queue register support to perform pipelining operation by the 8086 processor. So which data you put first in that queue, that will be processed first. For example, we are standing in any one queue, like in ration shop or ED office, anywhere. So who will come in first in the queue, they will be served first. That is a fashion of the queue register. Like stack is reverse, it is last in first out. So when you arrange the book, which book you put in the last, that book will be take first. The later will take the last book, that above the order of books will taken first, like last in first out. That is a things to be followed by the stack memory. So already I explained about the multitasking. So a single processor, if suppose perform more than one operation at a time, that you called by multiprocessing. So as per the contents, that is index page, what I mentioned there, the generation and features of the every processors explained. Buses, that was explained in the beginning. What is bus? What are the buses and their functions? Bus is where it's used to carrying the information or the address from one place to another place. 3 category of bus: address bus, data bus, control bus. And third contents in the index is stack and queue. I just now explained what is stack and what is queue. Then pipelining. What is pipelining? It is kind of parallel operation. Instead of doing one process after the next process, that you are perform the 2 parallel operations together, that is explained through pipelining. And explain now interrupts, and shortly explain about instruction set and timing diagram. Timing diagram is a graphical or the pictorial representation of the instruction, how it is executed stage by stage. So the instruction set were explained like arithmetic instruction, logical instruction, data transfer instruction, machine control instruction, stack related instruction, push and pop, stack related instructions like push and pop, and machine control instructions. That are some of the major category of the instructions. Addressing modes just highlighted, and advantages highlighted. Applications. The microprocessor applications are from a single toy to even the recent updates anywhere, all the places the microprocessor applications are there in aeronautics and satellites, all communication system. Wherever the recent developments there, all the places the microprocessors taking important and vital role. And about memory partitioning. Memory partitioning is one of the important concepts in microprocessor, to divide the memory, partitioning the memory for easy access of memory locations. The memory segmentation is a concept is important in 8086 processor. You segment your 1 megabyte memory into 464 kilobyte of segmented memory, and each memory is how to be accessed with the name of code segment, data segment, stack segment, and extra segment. So memory partitioning, that is the major advantage of the partitioning, to easily access the memory locations. And the last one, according to the index, it is multitasking. That also explained there. A processor, if perform more than one process at a time, that you can say as multitasking. So I'm going to summarize this. In this webinar, we are just started from the generation of the processors and the features of each processors and what are the architectural features from 4004 to i7 processors, the advancement, architectural advancements, these and their applications and its advantages, Ingress, instruction set, all the things are, the outlines are just given. So this is the overall summary about this today's webinar. So thank you.
Thank you, Professor Dr. T.S. Arlananth. Thank you for your wonderful webinar on advancements in processor. So I take this opportunity to thank each and everyone. First of all, I thank Dr. T.S. Arlananth, who gave an inspirational speech on webinar on advancements in processors. Next, I would like to thank our management who provide such a wonderful environment for conducting this webinar. Next, I would like to thank Dr. Jaykumar, General Manager Development, SCAD Group of Institution, for motivating us to conduct this webinar. Next, I would like to thank Dr. V. Velmurugan, Principal, Francis Xavier Engineering College, Mr. S. Krishna Kumar, Director Alumni, Francis Xavier Engineering College, Professor P. Brinda, Head of the Department of Computer Science and Engineering, Francis Xavier Engineering College, for motivating us and guiding us to conduct this webinar. So finally, I would like to thank all the participants who gave their support for the successful conduct of this webinar. So thank you all. Thank you for your cooperation. Thank you all.